video, we'll just focus on actually the drawing by itself. For this video, you will need a protractor, a ruler, and we're going to use centimeters, some sticky notes, a few different colored pencils. All these are optional. You can use markers as well, and some of this translucent patty paper, but we won't use this until the very end, so you won't need this just yet, only in the last few things we're going to do. First, we'll start with reflections. We're going to skip all the introductory stuff and go straight to the construction. So, first, construct the line of reflection between the pre-image and the image. So what we've got to do is try and draw that line of reflection, the line of symmetry. Now, there's a couple ways to go about it. We know that the line of symmetry has to be a perpendicular bisector. So bisector means if I draw the lines from my pre-image to my image, like this, I'll connect the corresponding points. Okay. Then I should be able to find the midpoint of those to draw my bisector. So there's a couple ways you can find your midpoint. One way is to measure. So this is about 6.2 centimeters. We see that right there, 6.2 centimeters long. So my midpoint is going to be at 3.1 because that's 6.2 divided by 2, so 3.1 right there. My midpoint. Another way you could do it is to use your sticky note, okay, and carefully place it along the distance right here, like that, and fold it halfway between your pre-image and your image. So just like this. Okay? And by folding the paper halfway, you're effectively finding your midpoint. So just like that. And again, you could do the same thing, or you could measure for A and A prime. Just going to line up nicely. Okay, I've got to fold to there. Okay, and there's my midpoint. Again, I could have measured and divided by 2. Once you've got all your midpoints, you can go ahead, take your ruler, and draw your bisector right there, just like that. And that is the line of reflection between those 2 points. Pause the video now. Go ahead and draw the line of reflection over here. The answers will be coming up in 3, 2, 1. So hopefully you should end up with a line of reflection similar to this. In the next section, we're asked to reflect the pre-image over the line M and N. So we have to take this pre-image and reflect it over there to make an image, and this here and reflect it over this line to make another image. So remember, when we're drawing reflections, the line of reflection serves as a perpendicular bisector. And so the word perpendicular is going to be very important here. We're going to use our sticky note, the corner of our sticky note, as a right angle in this part right here. So what I'll do is I'll start by reflecting each point to the other side. Let's start with B. I'm going to take my sticky note and line it up so that, okay, this sticky note is aligned right here with the side. You can see that. So it's there. And also so that this hits B. What that does is it allows me to draw this line right here and ensure that this is a perfect right angle because I've used my sticky note to draw it. Then I will mark where B is, right here, and take the sticky note and flip it to the other side. And this is what allows me to have the bisector, the congruent part. Line it up, and then keep this line going here to the other side, and draw where B prime is going to land, right there. So that's B prime. Again, the corner of the sticky note gives me the right angle, the perpendicular, and copying the length of B to the line M gives me the congruent part, or the bisector part. So I'll go ahead and finish this out the same way with all the other points. So C, and we go to the other side, make that congruent segment again. Okay, so C prime. I'll do with A. Again, I'm making sure that everything is lined up perfectly. Okay, so you got that right angle right here. Okay. Oop, mark where he is. So flip it over. Okay, line it up. Beautiful. Okay, there's A prime. Again, I'm getting my right angle from the corner of the sticky note and the congruence from the fact that I am copying these segments with the sticky note. Okay. this, right angle there. Oh, and D is right there. And so, okay, make sure this is perfectly lined up again. Okay, here's D prime. And now that I reflected all the points across this line of reflection, I've ensured that they are all right angles, and I've ensured that they are all congruent both sides, making that a bisector. I can go ahead and finish out by connecting these points and seeing my reflection. Okay, and if you look at this, you can see that I've done a pretty good job of reflecting this, looks like a trapezoid, across my line of reflection to the other side. Another method for constructing a reflection is to use a ruler like this. First, we need to make sure that our line of reflection is perpendicular to the line connecting the image and the preimage. And so to get that, first pick one of the longer lines here on your ruler. I'm going to pick the 10 centimeter mark, and make sure that I line up my little mark right here with the line of reflection. So this would not work. I've got to line that up. So it's perfect right there. And there it is. This will ensure that I get a right angle right here. Next, I need to make sure that my line of reflection is a bisector, which means that I'm going to start with B. Now, if I draw a line from B to my line of reflection like this, again, I have that right angle there, I can see that B is 1, 2, 1, 2, 3, 4. I'm thinking about 2.4 centimeters to one side. So I'm going to have to extend my line 2.4 more centimeters to the other side of that line of reflection, and that is B prime. And then I continue to do that for all my other lines. So I'll go for C now. I'll line up my ruler so it's a nice right angle there. And C seems to be 1.4 to that side, and so I will reflect that to 1.4 centimeters to the other side. Again, I lined that up so it's a right angle, and I made sure that both sides were congruent, so I can put those symbols there. And you continue to finish out this just like before, draw the rest of the points, and then connect those points to create your image. There's also two ways to ensure that your reflection is correct. Now, these aren't ways to do the reflection originally, but they're ways to check it. One way is with this translucent transfer paper or patty paper, sometimes called parchment paper. What you can do is, using a marker or a pencil, a pen will not work well, is trace your line of reflection and trace your original image. Okay. And then take this and reflect by flipping it over and placing it back on the line, and hopefully your image should line up. And look, B prime and C prime that I've done from before do line up. So it looks like I've started my reflection correctly, and I'll just have to continue using either the ruler method or the sticky note method to finish this out. One last way to make sure your reflection is correct is by using a mirror. A mirror looks like this. It is a translucent mirror made of plastic. It lets a lot of light through, but also gives you a very faint reflection. What you can do is take this mirror and line it up on your line of reflection. Make sure it's directly on top of it, just like that. Okay. And if you look through it, you can see that there's a reflection in there of the trapezoid ABCD. And if you look closely, you can see that B prime, our point that we plotted from before, and C prime are right on top of B and C, which is where they should be. This is a good way to check to make sure you've done your reflection correctly. You can take it a step further and try and plot, it's a little tricky now, where D prime, okay, and where A prime are. Now, like I said, this isn't the most accurate method because we're not measuring or anything. We're just going based purely on this mirror reflection. But it's a good way to get an idea of where the reflection should be. It's also nice because you can experiment with reflections. If you change the line of reflection, you can see what happens to the reflection very easily on this, right? So you can kind of get a sense for what reflections actually do and how they work. As always, whenever you're done, go ahead and connect your points. Remember, we know that distance and angles are preserved under reflections. Right there, they're all congruent. So all you need to do is reflect those points, and once we connect them, we have the same figure. That looks like a pretty clean reflection. Go ahead, pause the video now, and try and reflect this. The completed version will be up on the screen in 3, 2, 1, and here's the completed reflection right here. You'll notice a couple of things, that although most of the points are on this side of the pre-image, D started over here. As a result, D has been reflected back to this side, while the other points are over here. So just because this polygon crosses the line of reflection, doesn't mean all the points are going to shift to this side. They're all going to shift to the opposite side they're on before. So you can kind of see they intersect like this, and it looks like a pretty accurate reflection. Sometimes coordinate grids are helpful when drawing reflections when rulers, protractors, and other tools are not available. Try completing the following reflections that we have here. I'll do the first one with you, and then I'll help you find the line of reflection for the next two, and then you'll try them by yourself. So let's get started. Remember, this little r means reflection, and then I'm reflecting over the y-axis, and I'm going to move, let's see, F, M, Y, Z over that y-axis. So let's see here. First, I'm just going to bold my line of reflection. So this is the y-axis, that's what I'm going to reflect over. And then I need to reflect this FMYZ quadrilateral. So the nice thing about a grid is that you can simply just count to the line of reflection and make sure it's the bisector. So F is 1, 2. So 1, 2 more gets me F prime. The other nice thing is that since it's a grid and all of these are square boxes, they all have right angles. So just by simply counting, it's automatically a perpendicular bisector. I can just end it with Z, 1, 2, 1, 2 on the other side. That's Z prime. And then Y, 1, 2, 3, 4, 5. 1, 2, 3, 4, 5. Y prime. And then 1, 2, 3, 4, 5. 1, 2, 3, 4, 5. So there's M prime. And then I take my ruler and just connect those points and draw the reflection across the y-axis. And there it is, right? A little simpler that way. Let's look at 2 and 3 for a second. 2 and 3 have different lines they're reflecting across, and I want to make sure you know what these lines are. In number 2, it says, reflect across y equals negative 1. Think back to Algebra 1. How do we draw y equals negative 1? Well, it's a horizontal line going across like this, and to draw it, we go to the y-axis, where y equals negative 1. So here's the y-axis, there's y equals negative 1. And then all the places where y equals negative 1 are right here. We draw a horizontal line going right through that axis. That's what I've got reflected across. I'll let you do that in a second, but first, let's look at 3, get the line for that going. Okay, reflect across y equals x. Now, if you remember from Algebra 1, the equation y equals mx plus b, y equals x is like y equals 1x plus 0. So it's got a slope-intercept, or it's got a y-intercept of 0, and a slope of 1, so over 1, up 1, over 1, up 1, over 1, up 1, over 1, up 1. This is the line y equals x. Okay, y equals x. So let me just draw this line. Okay. And now pause the video. Go ahead and try and draw the reflections for numbers 2 and 3. Pause the video now. The answers will be up in 3, 2, 1. Here we have the reflection number 2. The important thing to watch out for here is that when you're counting to your line, this is your line and not the x-axis. So, for example, C is 1, 2 squares away from the line, so we have to make C prime 1, 2 squares on the other side. So watch out for that. Number 3 is a little tricky as well. Since we're reflecting across a diagonal line, when we count towards this line, we can't count up or to the sideways. We have to count kind of this diagonally, so we're coming directly perpendicular at this line. So for example, M is 1 diagonal square away from the line, so we have to go 1 to the other side. Or P is 1, 2, so we've got to go 1, 2 diagonally. The reason is because if we don't count diagonally, we're not getting that perpendicular bisection. That's so important that this approaches at that perpendicular bisector right there. If you try and count to the left or the right, again, that will not be perpendicular. You won't have the right answer.